Welcome to EPG Pathshala. I am Aparna, working as scientist, Quality Control Laboratory, Professor Jaishankar, Telangana State Agricultural University, Hyderabad. Today we are here to learn about emulsions, the properties of emulsions, types and different kinds of emulsifying agents. Among the structures and different kinds of structure forming units within the foods, emulsions have a very major role to play in the food as well as different kinds of food products. They are known to impart very good quality, mouthfeel, different kinds of characteristics which are sensorily appealing to the food. But in addition, apart from that, they are also the key ingredients in formation of different kinds of structures in certain products. Like for example, if you take whipped toppings, ice creams, creams, etc. Then they are also very important in more structured and more complex products like the processed cheese, etc. Therefore, the understanding of formation, the structures of emulsions, properties of emulsions, the types of emulsifying agents is very important, and one should understand the importance of all these things. So the formulation and creation of a food structure which involves emulsions, it always compromises and it always depends on desired qualities in the food and the materials in which these emulsions are used. First, let us know about the various kinds of emulsions. Now, among the emulsions, we have 4 different kinds of emulsions. The first one is oil in water emulsion, second one is water in oil emulsion, the third one is water in oil in water emulsion, and the fourth one is oil in water in oil emulsion. Let us now try to understand each one of these. The first one is oil in water emulsion, which is very commonly found in the regular foods which we consume. The oil in water emulsion has got droplets of oil which are suspended in an aqueous continuous phase, and they are very versatile kinds of emulsions, and they exist in different kinds of forms. For example, mayonnaise, cream liquors, the creams, whipped toppings, ice cream mixes, etc. contain these oil in water emulsions, and their properties can be controlled by varying both the surfactants which are used as well as the components present in the aqueous phase. Now, after the first kind of emulsion, let us now move ahead to the second kind of emulsion, that is the water in oil emulsion. Now, coming to the water in oil emulsion, you have different kinds of food products like butter, margarines, the fat-based spreads, etc., which come under this water in oil emulsion. Now, these depend for their stability more on the properties of the fat or the oil and the surfactant which is used than in the properties of the aqueous phase. Because of this, you will see that there are very fewer parameters which can be varied to control their stability. So as the name indicates, water in oil emulsion will be different kinds of foods like the butters, margarines, etc. Let us now move ahead for the third kind of the emulsion, that is the water in oil in water emulsion. Now, this water in oil in water emulsion, it is a oil in water emulsion whose droplets themselves contain water droplets which are nothing but water in oil emulsions. These are most difficult kind of emulsions to produce and control because the water droplets which are contained in the oil droplets must be stable, and the oil droplets contained in the aqueous phase also should be stabilized. Then we have the fourth kind of emulsion, that is the oil in water in oil emulsion, which is a double emulsion system in which the dispersed phase is a oil in water emulsion and the continuous phase is either oil or a plastic fat. Because of its limited applications in the food products, comparatively limited work and research has been done on these oil in water in oil emulsions. For the convenience of description, we may divide the oil in water food emulsions into 3 different classes again, depending on how they are to be used. The first class contains emulsions which are end products by themselves. For example, you have the coffee creamers, cream liquors, etc., which are very relatively simple and different simple kinds of emulsions whose only requirement is to remain stable towards the creaming and coalescence during their shelf life. Now, these emulsions present less of a challenge to the processor than the different kinds of complex emulsions. There are a few basic rules for formulation which allows successful products to be created. The second class of emulsions, they contain those which can be used as ingredients that participate in forming the structures of more complex products, that is, different kinds of proteins, polysaccharides, etc., which form a matrix in which the fat globules are trapped or with which they interact. Examples of this second class are yogurts, processed cheeses, different kinds of gelled food products, etc., which contain emulsion droplets which interact with other components in the food but are not destabilized in the entire process. Their effect is usually to alter the rheological properties of the gel, and therefore they create a very good desirable texture as well as mouthfeel. Then in the third class of emulsion, the droplets are required to create new structures during processing, such as in ice creams or whipped products, where the emulsion is destabilized and further interacts as a means of creating structure in the product. Some emulsions themselves may also form gels during the heat to create new structures within the food. Then let us now go to the emulsifying agents. You have these different kinds of emulsifying agents which are soluble in either fat or in water, so that they will uniformly disperse either in fat or in water. Emulsifying agents are also called as emulsifiers, and they are present in foods like butter, mayonnaise, salad dressings, etc. They usually have one hydrophilic and one lipophilic part, and these agents surrounds the oil droplets in water and reduces the tension between the two liquids that impart the stability to the emulsifiers. Let us now look at the classification of emulsifying agents. The emulsifying agents are classified on the basis of chemical structure and the mechanism of the action. Under chemical structure category, you have synthetic, natural, auxiliary agents, and finely dispersed solids. In the category of mechanism of action comes the monomolecular, multimolecular, and solid particle films. You have the natural emulsifying agents also, which are derived from both plants as well as animal tissues, and mostly in the form of hydrated lipophilic colloids. These emulsifiers make the protective sheath around the droplets, give the droplets a charge so that they repel from each other and swell to set up the viscosity of the liquid. Natural ones are derived from vegetables, animals, semi-synthetic and synthetic agents. Although natural agents are inexpensive, safe and non-toxic, but they are very slow in action. Therefore, a large quantity of emulsifier is generally required for proper action when you are using the natural emulsifiers. Then we have the animal derivatives, which are stronger than the plant derivatives. The best example of the animal derived emulsifiers are lecithin and cholesterol. Generally, some people are allergic to these lecithin, and therefore it is very important to know the composition of the emulsifier used to avoid any kind of food allergens, etc. Then let us now move ahead to the next topic, that is the properties of emulsifying agents. An emulsifier generally consists of water-soluble hydrophilic parts and water-insoluble, oil-soluble lipophilic parts within them. When an emulsifier is added to a mixture of water and oil, the emulsifier is arranged on the interface, anchoring its hydrophilic part into water and its lipophilic part into the oil. On the interface surface of water and air and of oil and air, the hydrophilic part and the lipophilic part are adsorbed and arranged around the interfaces. The interfacial tension is reduced by the emulsifier. That is, the force to separate the oil and water is very weakened. resulting in easy mixing of oil in water. There are many important properties of emulsifiers which are applicable in many kinds of food systems. The first one is emulsifiers act as surface active agents. When a water droplet is in the air, surface tension, that is a force to reduce the surface area, acts on the surface of the water. This results in spherical water droplets. When water and oil are present in a container, they cannot be mixed together thoroughly and they keep on separating. In spite of constant stirring, the separation of two layers of water as well as oil takes place. When two immiscible substances are in contact, the contact surface is called the interface. And the interfacial tension is a kind of surface tension which acts on the interface so that the two substances separate from each other. Now, the emulsifier agents can reduce the interfacial tension and they can bring together both the immiscible liquids. As the interfacial tension increases, the force to separate two substances become very strong. And the surfactants weakens the interfacial tension and changes the properties of the interface. Then let us go to the next property, that is HLB. The hydrophilicity and lipophilicity are different among emulsifiers and the balance between the two is called as HLB value. Now this HLB value, it ranges from 0 to 20. An emulsifier with higher lipophilicity shows a lower HLB value, whereas a higher hydrophilicity has got a higher HLB value. And the behavior and functions to water depends on the amount of the HLB value. All compounds that have the hydrophilic parts and the lipophilic parts are not always usable as an emulsifier when the hydrophilicity is too great. Such compounds disperse in water and the ones with greater lipophilicity would disperse into the oil. And when the hydrophilicity and lipophilicity are well balanced, the emulsifier, it exhibits a very good stability in the food systems. Then we have the third one, that is the Myceli formation. Because an emulsifier has opposite properties, hydrophilic and lipophilic, its solution does not become a simple aqueous solution, but it becomes a colloidal solution of which the properties vary differently depending on the concentration in the colloidal solution. In an extremely diluted solution, there is no special change, but the emulsifier gathers on the interface and the surface tension is usually reduced and an increase of its concentration is seen. Then let us move to the next one, that is the solubilization. When a small amount of insoluble substance is incorporated into an emulsifier myceli, semi-transparent solution is produced and this phenomena is called as solubilization. Solid monoglyceride has a large capacity of crystallization which generally affects its performance. It also makes a liquid crystal which has intermediate characteristics which is between solid, crystal and a liquid. And the form varies with the kind of emulsifier, the temperature, its concentration also. In practical applications, it is necessary to select a suitable emulsifier with consideration to conditions including the temperature as well as the food constituents. Now, after seeing the properties of the emulsifying agents, let us now learn about the various functions of emulsifying agents. The use of food emulsifiers, it began with production of different food products like margarine, etc. And these compounds were commonly prepared with emulsifiers. Generally speaking, an emulsifier is a compound with emulsifying effects which actually has its functions and it exhibits its functions by holding the water and the oil components together in the food product. For example, to modify oil crystal and prevent water spattering in cooking. Then in ice cream, an emulsifier does not promote emulsification but rather destroys emulsion to stabilize the foam and to make a product which has a very smooth texture, and also it helps in keeping the properties of the ice cream. In bread, an emulsifier reacts with the protein to make a smooth and easy riding dough with no relation to the emulsification. It also acts on the starch to make the bread soft. Now let us go into the details of the functions of emulsification. Oil and water produce emulsion by stirring. However, the emulsion generally starts to break down immediately after the stirring, and you see that the oil and water separate off very quickly. The aim of emulsification is to stabilize emulsion by preventing the breakdown. The breakdown of emulsion occurs during creaming, during aggregation, and during the coalescence. To solve these kinds of problems, there are different kinds of measures which have been taken. That is, decreasing the size of dispersed particle, reducing the density of difference of dispersion, and to protect the surface of the oil droplets. There are two types of emulsions, that is, the first one is the oil in water emulsion, which we have already discussed, where oil droplets will be embedded in water, which can be found in ice creams, milks, etc. Similarly, we have the water in oil emulsion, where you will see that the water droplets are embedded in oil. For example, butter and margarine. Now you also have the oil in water in oil, water in oil and water emulsions also, which are complex emulsions, and these kinds of emulsions are being slowly used in the food applications also. These multiple type of emulsions not only make low calorie food items like creams which contain less amount of oil, but also stabilize the emulsion by dissolving the unstable substance which is present in the water droplets. Apart from that, taste also can be enhanced considerably by injecting seasonings, flavors, etc. into the water droplets. Then the second function is dispersion. Now coming to the dispersion function, generally the water insoluble fine powder like cocoa, etc., it is very difficult to disperse as small lumps form on the surface of the interface whenever you are using it in any kind of food preparation. Powders gradually aggregate and precipitate even if dispersed by shaking. Maintaining suspension of such water insoluble particles or fine powders is called as dispersion. When the dispersing material is liquid, we call it emulsion. Cocoa drinks are produced by dispersing cocoa powder in water, and chocolate is made by dispersing it in oil. Emulsifier absorbed on the surface of insoluble fine powder changes the particle surface to be hydrophilic or lipophilic, the results of which produce soluble water or fats and oils at outer layer and stabilize the entire suspension by increasing the affinity to the water or oil in the outer phase. Then the third function is foaming. Foaming ability is one of the most important and major characteristic of any kind of emulsifier. When a solution containing an emulsifier is stirred, the emulsifier is adsorbed on the surface of the produced foam to make a monomolecular layer, and the foam outside of the solution makes a bimolecular layer of the emulsifier. The film surrounding a soap bubble is around 100 times thicker than a biomolecular layer, but a bubble breaks as soon as migration of the liquid trapped between. The foaming effects are utilized for production of different items like creams, etc. The addition of an emulsifier enables foaming ability and stabilization action. Thus, you will see that smoother texture can be obtained as well as expanded volume can be obtained in the products where you are using the emulsifier as a foaming agent. Examples of this are cakes, ice creams, mousse, whipped toppings, etc. Emulsifier has also foam extinguishing property, and therefore it is called as anti-foaming agent also, or it is also called as defoaming agent. During food production, foaming may occur in the presence of protein, starch, etc., and an emulsifier with a foam extinguishing action can be used to stop the formation of foam in some kinds of food processing techniques. Foam extinguish has properties like it is water insoluble, floatable on the surface because of its small specific gravity and small surface tension, and easy spreading on the liquid surface. These properties ease the surface tension and so the foam becomes thinner, and these agents spread easily on the liquid surface and the foam can be stopped or foam can be diminished, and these are used in the production of tofu, jam, sugar, as well as in fermentation industry where foaming is not a desired property and you use emulsifier for defoaming in such kind of food applications. Then we have the next function, that is wetting. Emulsifiers can act as wetting agents. Wetting effects of emulsifier moisten the solid surfaces. Solid material is mixed with an emulsifier or its surface is spread with it, and the surface then becomes hydrophilic. For example, you have the chewing gum. Chewing gum is generally having the characteristic of sticking to the teeth. Adhesion to the natural teeth does not occur easily because enamel is hydrophilic and it is always wet. Whereas if a person has artificial teeth, the adhesion can happen very easily. But we can prevent the adhesion by wetting the surface of chewing gum by addition of an emulsifier. Then the next function is emulsifiers can act as bacteriostatic agent also. Emulsifiers have different kinds of bacteriostatic effects. Monoglycerides, polyglycerol esters of low molecular fatty acids have specific bacteriostatic effects which can be used as a bacteriostatic agent, especially in different kinds of hot vendor drinks, flour pastes, etc. Then let us see the next function, that is the function of emulsifiers on the starches. Fresh baked breads or cakes are very soft, elastic, but they harden over the time. The starch particles generally consist of spherical, spear-shaped amylose and amylopectin. Now the raw starch called beta starch is insoluble in water, but when heated to a certain temperature, the starch absorbs water and changes into a crystalline form of alpha starch, and the amylose gets hard easily with cooling, and amylopectin becomes hard gradually with the time. Now the immediate hardening of bread by cooling is mainly because of the presence of the amount of the amylose and the changes in the amylose content. So the amylose changes to a helix structure, which is a kind of spiral structure, by heating. If the monoglycerides are introduced, they can be anchored into the helical structure, and since the anchoring does not change even after cooling, you can see that the softness in the bread can be maintained for a longer period of time, unless when you add an emulsifier where the starch gets hardened. And this function can also be utilized for the other applications like mashed potatoes, noodles, rice, etc. The emulsifying agents also have a specific action on the proteins, which is again a very important function. When wheat flour contains protein called gluten, which takes the shape of a mesh-like structure when mixed with the water. This wheat flour and wheat-based dough is filled with carbon dioxide produced by a fermentation and steam generated during the baking process, which produces the loaf volume in the bread. When the gluten content is small or very less, the dough raising also will be very little. In such conditions, an emulsifier when added can modify the gluten molecules and enhance its film forming power, which results in good spreadability and improvement of the working efficiency, and therefore you can see that the loaf volume or the rise in the bread can be easily obtained by addition of an emulsifier. Then the last function is action of emulsifier on oils and fats. When fats and oils form into crystal, an emulsifier promotes and inhibits the growth, preventing the formation of abnormal crystals. This function is utilized for production of food products like margarines, shortenings and chocolates. So today we have learnt about what are the different kinds of emulsions. We have 4 different kinds of emulsions. Then we have also seen the properties of emulsions, and we have learnt about the various functions and applications of emulsions in various kinds of food applications. The object of making food emulsions is to provide stable and controlled source of food, whose texture, taste, nutritional and storage properties are well acceptable to any kind of consumers. Although the number of possible ingredients is limited by the constraints of healthy nutrition, it is nevertheless evident that within the available range, there is a very great deal of opportunity for variation in the properties of the emulsions. For instance, the particle size, the composition, stabilizing layer of the interfaces, which in turn can have a very good influence on the stability and functional behavior of the emulsions. On the other hand, many emulsions used in the foods have their roots in established formulations, and an understanding of why certain emulsions behave as they do is still not very clear, but the understanding is important in producing different kinds of foods in various kinds of food industries. To learn more about the emulsions, the properties of emulsions, you can refer to books like Food Chemistry by Nelson, or you can refer to Advanced Food Science and go for further understanding about the emulsions, its applications in various food uses and food applications. Thank you.